All right, folks, it's Bass Action, back in action here. In this video, we are going to continue our lesson on law of cosines, but now we are going to solve for a side. Now, you can always work with this formula and go through the process that we're going to do here in a moment. You can always do this process repeatedly. I just would personally encourage you to try to get the pattern down and kind of work with the two different formats because it will make it a little faster for you. All right, what we want to do on this particular problem is we want to take this crazy formula that's all letters and we want to solve for this individual variable a. So this is going to really test our algebra skills, solving for a. So the first thing that we're going to do on this problem is we are going to visualize the left side is over 1 and we're going to cross multiply this. Okay, so we're just going to do a nice cross multiplication. A little tip on this, if you're going to take a cosine A times this number, take the 2bc and we're going to write it in the front. That's going to make it a lot easier for us to work with. So we're going to say our 2bc times, and we don't have to have the times, but it makes it a little cleaner for us, cosine A, and that's going to equal this product, which is of course just the numerator because it's times 1. So we're going to say b squared plus c squared minus a squared. Now, when you're doing this, you really want to keep your eye on the prize. What is it that we're trying to solve for? And what we're trying to solve for is this a squared. Now, you'll notice I highlighted that negative because I wanted to remind myself that this was in fact negative. So I have some number over here because all of these are numbers, okay? And I've got this negative of this a squared. So if I imagine adding a squared to this side and this side, it would move the a squared over here, and then I could subtract all of this and move it to the other side. What that's going to allow me to do is quickly clean this problem up, and it will become a squared. And now I still have the b squared plus the c squared, but I want to subtract this entire expression from the left side. So now I'm going to say minus 2bc times cosine A. And believe it or not, we are basically now done, because if we take the square root of each side to get rid of this exponent, square root, we now have A equals b squared plus c squared minus 2bc times cosine A, and it's the square root of that entire thing. Now, the reason this is still kind of handy, even though it looks like it's more complicated, is if you keep your mind on those piece fingers like we were talking before in the previous video, these are the piece finger numbers. So it's not nearly as complicated as it might initially seem. So let's take a look at an example because that probably still feels pretty abstract for some of you. So the first thing that we're going to do is we're just going to look at this example right here. Let's say we wanted to find the perimeter of this triangle. Same thought process. We'd say, hey, is it a right triangle? No, so we can't use any of those things. Can't use Pythagorean theorem or special triangles. We'd say, oh, it's not a right triangle, so we can't do SOHCAHTOA either. Do we know the measure of an angle and a side? And we'd say no, so we can't use law of sines. So we'd have to say we're going to use law of cosines, piece fingers. Now this time we know the angle, and we still are going to use then the angle we're going to focus on. Our piece fingers go on each side of it. So the shortcut, which is what we just did, let's say we wanted to find this x, we could say x equals, and then we're going to take our piece fingers. Now, I personally like to write the square root at the end, but sometimes students forget, so I'm going to draw it first for you. So I'm going to say the big square root, and I'm going to take my piece fingers, and just like before, I'm going to square them and add them together. Remember that order doesn't matter. Then I'm going to subtract, and I'm going to say 2 times my piece fingers. And that's going to be times the cosine of the angle that we have. If you type all this in your calculator, you will get your final answer. Now, here's a little tip. You've got your 100 squared, your 150 squared minus, when you get to this portion and you type it in your calculator, I would do a parentheses here, and I would do multiplication, multiplication, multiplication. I would not actually type these parentheses. I would type in what I have here in red. If you do that, you should get a value for the side of 97.6. Now, again, just like before, if you're struggling with the calculator, that's okay. As long as you know how to set it up, we can help you with the calculator in class. The other option is to kind of go through this the long way, starting with your good old angle formula. Say, hey, this time I have an angle, cosine 40, and you would start off just like before. You'd say, I know my piece fingers on each side of that angle. You would multiply those piece fingers times 2 in the denominator. And this time, when you went to subtract the square of the opposite side, it would be a variable. Now you can cross multiply this just like we did up in our initial proof. We would cross multiply this and say 2 times 100 times 150. You could actually write that out if you wanted. Cosine 40 equals 100 squared plus 150 squared minus x squared, and you would end up getting right back to what we did up above. So yes, you would add your x squared, you'd take this whole value and move it over, and you would still get your x value of approximately 97.6. So if you ever forget this setup, you can just go back to the angle setup. The last thing I want to look at is a new quick way to find the area of a triangle. We've done a lot of exact methods for the area of a triangle, but this one is going to be a convenient shortcut when you have a special pattern. Specifically, the pattern that you're going to need is a side angle side pattern, meaning you're going to need to know two sides and an angle in between. If you have this pattern, you're going to have a quick and easy formula for it. So this is going to be our little sample one. We're going to come up with a special formula for this. If we wanted to find the area of this triangle, we could, let's say, if we knew this side U, if we had the height of this triangle, okay, I'm going to call it X. If I had the height of this triangle, I could say that the area of my triangle, of course I know area is 1/2 base times height. If I could have this handy dandy height here, I could fill that in and I would know my area. But you can see we don't know this X, we don't know this height. So what we're going to do is we're going to look at the right triangle that I've created here, and we're going to find an expression for this height. So we're going to say, hey, we're going to know this angle P, so we're going to say the sine of P. And from P, we want this opposite, and we'll know this hypotenuse. So we're going to say x over y, and then we're going to cross multiply, and x is going to be equal to y times the sine of P. Now, if x is y times the sine of P, and we've already established that this x is going to be our height, and y is going to be our, sorry, I didn't mean y there. Never mind. Let me see if I can erase that. Sometimes my iPad freezes up when I try to erase, so we'll see how well this goes. Yep, there it goes. Okay, so what we're going to do is we're going to take our u, u is supposed to be the base. So we've now come up with an expression for the height, and u is going to be the base. So our formula is going to be area is 1/2 u times y times the sine of P. These will be the sides that are given, and this will be the angle that is given. So let's look at a really quick example here. So I've got a triangle here, and what we want to say is, ooh, look, we have side angle side pattern. And if we have a side angle side pattern, no math creation has to be done, we're just going to take 1/2 and our 100 and our 150. This is the easiest formula ever. And the angle, the sine of 40, and we just type all this in our calculator exactly as you see it, and you get the area of your triangle is 4,820.9. I'm going to go to tenths, and we're going to say unit squared. Ta-da, it will be the easiest one. So if you're given an area problem and it looks like it might be a lot of work, take a little peek. If it's side angle side, you can use this handy dandy formula.